Hi, welcome to another EC&M Tech Talks. Today we're going to talk about the different methods for grounding and bonding that we find in Article 250 of the NEC. First of all, we're going to talk a little bit of background information about this whole concept of grounding and bonding and making the connections properly. Then we're going to get into the general rules themselves. We want to take a look at the bonding connections. We'll be taking a look specifically at the items listed in section 250.8. And then we're going to talk about how we make a connection to the grounding electrode themselves. And then finally, we want to talk about bonding, really. We're going to talk about the EGC, right? The equipment grounding conductor, and how we make those different types of connections, okay? So let's jump right on in. You can't overstress the importance of proper grounding and bonding, right? In fact, as I always say, if you need to come up with a little tech talk of your own or safety toolbox meeting or whatever, go do some research on the internet and you'll find lots of information. For instance, you probably know, and maybe some of you like me are old enough to remember, back the worst electrical fire we ever had in the United States was a grounding and bonding fault, really a bonding fault. It happened back in the 1980s in Las Vegas, and 85 people died in that one fire. And what was the cause of that electrical fire in that hotel? Well, it was a lock nut, according to the fire marshal there. There's a lock nut that was not securely fastened into a box. And that connector, that conduit, the metal box, and so forth, was all part of that equipment grounding path. Well, with that high resistance connection, because of that loose lock nut, heat was produced and they ended up with a fire in the building. 85 people died. Pretty tragic. Another big area we've been concerned with in recent years when it comes to proper grounding and bonding is electric shock drownings. The Electrical Shock Drowning Institute, I believe it is, anyway, they tell us that there are probably several dozen incidents every year. And this is where someone goes swimming at a dock, which is not a good idea, where boats are sitting there on the dock. The boat comes in, it plugs into the ground power on the pier, and there's a ground fault in the boat. And so the current flows properly through the shaft and the propeller, and all of that flows into the water, and someone swimming nearby. And of course the current is returning through the water and going back to that transformer ground connection back up on the shore. Well, it may not be a huge amount of electrical current, depending obviously, but it can be enough that it can literally, paralyze someone in the water, and then they can't get out and they end up drowning from that electric shock. Really, is what it boils down to. So those are quite tragic. So another good reason that we want to eliminate the possibility of ground faults whenever we can, certainly. How about power tools? Man, we always hear about that, don't we? Somebody plugs in a power tool, it's improperly bonded, grounded, not using GFCI protection and so forth, and we end up with a tragic incident. Neutrals not properly torqued, okay? And loose neutrals can cause us a lot of problems in our distribution system. Certainly the neutral is a grounded conductor, and if it's not installed properly, torqued properly where it needs to be and so forth, we can end up with problems. Now keep in mind that we're talking, the whole purpose of the code, remember, is to prevent electric shock and to prevent fires. That's why we're concerned with proper grounding and bonding, really. We don't want anybody to get shocked or electrocuted, and we certainly don't want buildings to burn down. But the Electrical Safety Foundation Institute, the ESFI, tells us that 4% of our electrical fatalities in the workplace, and we have over 100 a year, usually somewhere around 120, 130 so, which is way too many electrical fatalities just in the workplace, not in our homes. They tell us that 4% of those fatalities are caused by ground faults. If we do our wiring properly in our buildings, our installations, if we follow the rules of all of the rules of the code, but certainly Article 250 for proper grounding and bonding, we should be eliminating all of those. We shouldn't be having fires. People shouldn't be dying in fires, and people should not be shocked and electrocuted on the job. And in addition to that, of course, we have ground fault circuit interrupters for people protection and ground fault protection on equipment, all required in the NEC then. So Let's take a look at 250.8. 250.8. I'm going to show you some things here, but then we'll take a look. I'll put some pictures up on the screen that will make it a little bit easier for you to see. So let's go through and look at there are actually 8 things listed in 250.8 where it talks about connection of grounding and bonding equipment. So 250.8 tells us that, hey, look, when you make your grounding and bonding connections, you have to use one of these 8 methods to do that. And those 8 methods, several of them are listed using listed devices. Let's talk about that. The first is listed pressure connectors. Next is terminal bars. Pressure connectors listed as grounding and bonding for grounding and bonding equipment. So I can't use them in anything else, just for grounding and bonding equipment. Exothermic welding, which a lot of you are familiar with. Machine screw type fasteners that engage not less than 2 threads or are secured with a nut. Well, we'll talk about that. The 6th way is thread forming machine screws. Thread forming machine screws that engage not less than 2 threads in the enclosure. We'll figure that out. Connections that are part of a listed assembly. Obviously, if the assembly is listed, we're okay to make our grounding connection there if it tells us that. And then other listed means. Well, that could be almost anything, couldn't it? So we'll talk about where we can find that information. So let's go through and let's look specifically at some of these devices. First of all, listed pressure connectors. Listed pressure connectors, and I'll put a picture up on the screen. That's probably the best way you're going to see it. But wire nuts, right? Twist-on wire nuts, we commonly call them. They are listed pressure connectors. UL, 486 or whatever, lists these. So if we take a look at what I put up on the screen now, you see over on the far left, you'll see one of these little greenies, we call them. It's a twist-on wire connector. It's green in color, and it's got a hole in the top. Well, that makes it kind of convenient to use because I can take my solid conductor and poke through that hole and connect it to the box or whatever it is I need to do. I don't have to use a green wire nut when I'm doing grounding and bonding. I could use that red twist-on wire connector. That would work just as well. The thing I want to be careful of, though, I don't want to take and use that green color that you see up there with the hole in the top on that pressure connector. I wouldn't want to use that on ungrounded conductors, okay, where they could come through and make contact with something and end up with a ground fault in my system. We have the red twist-on pressure connector, wire nut we'd commonly call that. And yeah, by all means, we can use that for grounding and bonding purposes. The little fork terminal that you see with the plastic on top, the plastic is not there for insulation. The plastic just simply tells us that what size conductor I can put, AWG-wise, I can put into that little crimp-on terminal. So that crimp-on terminal is listed. I must make sure that I always use the proper tool in order to crimp that device in place. Make sure that I strip enough of my conductor back if I'm using an insulated conductor for bonding and so forth. But anyway, and so that I make good contact on the inside. And usually I bring that conductor right out to the edge of where it's visible there on the forked side of that terminal. The barrel connectors that you see on the bottom, one has yellow on it, once again for telling us what size conductor we can put in there. And then once again, we use the proper crimping tool. The bare copper little barrel type lug that you see is very commonly used. Trade name on that you'll hear a lot. You might call it a bullet. Some people might call it a Buchanan, whatever. But once again, it's based on certain size stranded conductors, and typically, and then we use the proper crimping tool in order to crimp it down. Right now, it's nice you can buy those little bonding jumpers up on the top of the screen, the green bonding jumper. It's got listed pressure connectors on each end of it. The green terminal screw is not required to be listed. Green terminal screws are not. But it's got a green terminal screw in there that then, of course, we can attach to the box and make a good secure connection. Because remember, we've always got to the code tells us in Article 250, I've always got to maintain continuity with my equipment grounding conductor. Okay, however I install it, wherever I install it, connect it to a device, a receptacle, a switch, or whatever, I've still got to maintain, if I pull that switcher receptacle out, I've still got to maintain continuity for obvious reasons, right, to protect against ground faults. But I have to maintain the continuity of that equipment grounding conductor, okay? So those are some examples of some listed pressure connectors. Pressure connectors listed as grounding and bonding. And I said these are the ones that I can't use them for anything else. And here's some examples. Let's put them up on the screen again. And we take a look, and up on the top, somewhere here I've got a grounding bushing, but you can see the one up on the screen. Now, most of these devices are I can only put one conductor in there, one conductor of a certain size, whatever it specifies, okay, or range of AWG sizes, right? Now, the grounding bushing on the top, it's very obvious. I put that on the end of my con. I run my grounded conductor underneath the set screw and, of course, tighten it down. If torque specifications are there, I follow my torque specifications, right? On the right-hand side, the upper right-hand side, you see what's called an split bolt, and I've got one here. And certainly it's listed for grounding and bonding, so I don't use this for phase conductors and then tape it up. Okay, it's not listed for that purpose. It says on it, it's printed on here, somewhere there's the conductor AWG sizes and the number of conductors that I can put under this nut, okay? And then tighten it down. So follow my manufacturer's instructions. Remember 110.3 says I've got to do that. Other things like the ground clamp, you see, we'll use ground clamps on water pipes, for example, in the bottom right. And then the clamp for the rod, the ground rod, right? That's what we see on the bottom left. The things that I've seen on that is, for some reason, once in a while I've seen where there's more two conductors underneath that clamp, and that's not right for that ground rod clamp. Usually they only specified for one particular conductor and conductor size and rod size and so forth. So you make sure that you follow those requirements. And I also ran into a case at a very important military installation where actually the grounding electrode conductor was placed underneath the bolt side on the rod. So the bolt was actually tightening down into the conductor itself, and it should be on the opposite side, shouldn't it? And as we tighten the bolt down, we tighten into the clamp and pull the whole connection in nice and secure. So those are pressure connectors listed as grounding and bonding. Just some examples of them. Once again, UL 487 covers all of that. Something else, in fact, this is actually a picture off right here behind me, this panel board we've installed. And we've got an intersystem bonding termination down at the bottom of that panel board. And it's required by 250.94. 250.94. Now, it doesn't have to be this type. I can do it different methods. This is just one example. But this is a listed device, an intersystem bonding termination. In fact, at the bottom of the picture, you may see the UL label down there and some information. But it says that I have to take all of my communication systems and I'm going to bond them to my grounding electrode system. So here's an easy way to do that. There are 6 green terminal screws where I could bring in my conductors, grounding conductors from different parts or different communication systems. And then the larger black screw at the bottom is the one that actually goes through and makes contact with that grounding electrode conductor running through there. So that's 250.94 then. That requires that intersystem bonding termination, where you'll find the information on that. Another method then we said that we could use would be something like an irreversible crimp connector, okay? And so here, this is obviously listed for more than 2 conductors, or else it wouldn't work very well. Or more than 1 conductor, or else it wouldn't work very well, would it? So the appropriate size conductors have been placed in there. The proper type, it may be a listed crimping tool, that takes and applies that crimp and tightens those conductors down on the inside. So certainly that is permissible. If I get a piece of equipment and that enclosure is listed, the equipment is listed, it may have some indications in there where it wants me to connect my bonding jumpers, grounding electrode conductors, whatever the heck it is, okay? And so this particular piece of equipment is pretty obvious. In fact, in Article 250, it does give us an image of what UL I've heard referred to as, they call it an inverted Christmas tree. But nonetheless, that little green image on the bottom right shows us it's a grounding symbol, isn't it? One of the two types of grounding symbols that we'll see. The other type is an IEC symbol that you may see, and that kind of looks like a pitchfork, right, with the prongs pointing downward. But anyway, so this becomes an obvious point to make my grounding connection. You see my grounding, a bonding jumper has been brought in. It has a listed crimp on the end of it. It looks like that it's been made certainly with the proper type of tool based on the imprint that we can see on the plastic, and it's the proper size lug and so forth for that particular termination point. So anyway, so certainly we're allowed to make our bonding connections that way. Now, other listed means. What the heck? That's the last one here. Other listed means. That could be almost anything. The resource for you on that is the UL White Book. The UL White Book goes through and it's divided up into many sections. It's hundreds and hundreds of pages long, but it covers our electrical equipment that we use. And it has more explanatory information regarding the listing and the labeling information, requirements on that piece of equipment. So when it comes to other listed means, this is an example of one. Here, I've got one right here. It's pretty small, but once again, better to see up on the screen, right? And that's that little clip. I place that in the box, or on the edge of the box. I clip it on. I can put my grounding or equipment grounding conductor then through that little clip. Now, I have to be careful because it doesn't tell me in the code anything about these little guys, right? But it's in the UL White Book, and the UL White Book says, hey, you can't use that on a round box, which makes sense, right? It's not going to work very well. It's going to work better on a square, octagonal box or something like that. So anyway, those ground clamps are examples of other listed means then, okay? And refer once again to your UL White Book if you need to on that. Some of the other requirements when we make up these connections, 250.10 and 250.12. 250.10 says I have to protect my ground clamps and fittings from damage, right? Which makes sense. If they're exposed to physical damage, I have to enclose them in metal or wood or an equivalent protective covering. Look up equivalent protective covering in your NEC Article 100. You won't find it, okay? So what do we mean by equivalent? Well, once again, that's going to have to be something that's acceptable to the authority having jurisdiction, right? So use some common sense. Talk to your AHJ if you need to. If you run into a situation, anytime you run into that word equivalent, and make sure you're doing things right and in accordance with your requirements, okay? Clean surfaces. I have to have clean surfaces. I want to remove, it says, any paint or lacquer or enamel from not only from the enclosure itself, but also from the threads. Why? So I get good bonding, right? And that paint doesn't act as an insulator. Now, there are provisions because there are certainly things that I don't have to do that. So for instance, if I'm going to use something like, I've got a threaded hub here, right? And if I take this threaded hub apart, okay, around the edges of the threaded hub are some serrations and serrated, whatever, however I say that, right? And so when I put it into the box and I put this thing together and I tighten it down, what happens? Well, all these little serrated edges dig into that enclosure and dig through that paint for me. So that's certainly permitted. Even on a lock nut, something like a lock nut, for example. I look at the lock nut and the way it's constructed. On one side of the lock nut, it's pretty, those little edges are sticking out, okay? I can catch my finger on that. And so when I tighten that down inside of that enclosure, once again, I get through that paint and I make a good solid connection. So I have to protect my clamps, my fittings, my connections, and so forth. I have to clean my surfaces if needed to make sure that I get a good connection. Let's move on to another section now. That was 250.8. Let's talk about 250.64. 250.64 specifies the grounding electrode conductor installation. There's a lot of information here. It talks, for instance, at first it mentions, let me look at my code book here. It says, and by the way, I'm using the 2026 code book as we go through this presentation. so the 2026 NEC. But 250.64, that first section would be section A in the code book, talks about aluminum, copper-clad aluminum conductors. And it tells me that if they're aluminum or copper-clad aluminum, if they're bare conductors, I cannot bury them and can't put them in concrete, right? And it talks about it has to have a polymeric coating over it of some type and so forth. Also, something else that it tells me about those conductors, I can't terminate them within 18 inches of the ground, of the earth. Okay? Once again, corrosion issues with those conductors. For securing and protection of grounding electrode conductors, installing them, the grounding electrode conductor securely fastened along the building wall, whatever it is where I'm running it. 6 gauge and larger, I have to give them physical protection, those grounding electrode conductors, if they're exposed to physical damage. For less than 6 AWG, I've got to give them some physical protection. And it talks about, it lists the different types of conduits we can use to give them physical protection. Probably the most common is what? Schedule 80 PVC. And it does specify it's got to be Schedule 80 if you're going to use PVC. Ready? My grounding electrode conductors have to be continuous in length. That's my rule, my general rule. It does make provisions, so I can use things like irreversible crimp connectors like we saw earlier. I can use exothermic welding, which is that chemical process that's going to join those conductors together. A trade name, you'll run into that out in the field. CAD weld, isn't it, we use, but it's technically exothermic welding then. Maybe I'm using for my grounding electrode conductor, I have some bus bar inside a switchgear. So obviously the bolted connections of the bus bar, I'm allowed to use those. So anyway, it lists different provisions there that I can use in order to keep my grounding electrode conductor continuous in. If I have multiple disconnects, that would be the next section, in separate enclosures in the same building or on the side of the same building, whatever. So I've got multiple enclosures, multiple disconnects bringing my service in. I can use a common grounding electrode conductor. I can use individual grounding electrode conductors and so forth. It specifies those rules and details then in .64. So if I'm going to use raceways or cable armor, some type of enclosure that contains the grounding electrode conductor, I find the rules for those in A, B, C, D, E, section E, right, of 250.64. Installation to the electrodes themselves is covered in the next section, section E it would be. And then finally, I cannot, like on the transformers may be a good example. I have ventilation opening on the transformer. I can't take and just somehow, even if I need to make a hole bigger or whatever, I can't run my grounding electrode conductor through that ventilation opening. I can't run it through drainage openings and things like that, or mounting openings it specifies, okay? 250.70. 250.70 talks about making the conductor connection to the electrodes themselves. Pretty straightforward. Really, it's a lot what we saw in 250.8, okay? And so it says our ground clamps must be listed in 250.70. It says whatever I'm using then to connect to that grounding electrode, typically is only going to have one conductor as part of that connection. And what types of connection can I use? Well, I can use that exothermic welding chemical process. I can use listed lugs, listed pressure connectors that we saw earlier, listed clamps that we saw images of, and then other listed means. Once again, you'll have to look that up for other listed means in your white book or wherever, manufacturer's information and so forth. And finally, let's take a look at Part 7 of Article 250. A couple of items out of Part 7. Now, Part 7 is on methods of equipment grounding conductor connections. So we're not talking about the grounding electrode conductor now. We're talking about bonding equipment grounding conductors. There are rules in the NEC that if I'm going to take a receptacle that doesn't have a grounding lug on it, it doesn't have provisions for grounding as to what I can do. And those are elsewhere in the code, but it talks about I can use GFCIs. I can run an equipment grounding conductor to that receptacle that I am replacing. And so I'm replacing an older receptacle without grounding means, and I'm going to put a receptacle in there that does have that third prong down here on the bottom, right, of each receptacle. It's got that third prong then that I can connect to an equipment grounding conductor. So where do I connect my equipment grounding conductor? And that's what 250.130C talks about, where I can run that equipment grounding conductor. And I think there's 5 or 6 different locations. If you get involved in that, be sure and look that up. Make sure you're complying with that. .130C. But generally, what do we do with those receptacles? Probably, I don't know, in most cases, maybe you're giving them GFCI protection. So you have to follow those rules for installing those receptacles if you run into that. Then let's talk about one point maybe of confusion is 250.146, connecting receptacle grounding terminal to an equipment grounding conductor. Okay, so I'm going to take this metal box and I'm going to put a receptacle in here, mounted. So this particular receptacle, when I look on the back side, all it's got is a couple of black washers. There's no kind of little brass grounding devices that are permanently installed on either end of this receptacle. But I need to put it on this box. Well, if this box is surface mounted, meaning it's mounted on the surface of the wall, then I could remove one of these black washers, go ahead and install this receptacle, and that would count for bonding this receptacle then to that metal box. Now, if the metal box is flush with the wall, not recessed and not mounted on the surface, I'm just talking about it's made flush with the wall, in that case, I could use one of these receptacles that has this little, looks like a little brass, almost spring-loaded piece of metal on it. What's that for? That's for bonding, okay? And so I can use this receptacle and mount it in that flush-mounted box and get a good solid bonding connection to the box in. Other than that, I've got to run my bonding jumper to the box, okay, from the receptacle itself. So those are the provisions, some of the specific provisions that we run into for the equipment grounding conductor. Well, that's equipment grounding and bonding, okay? How we have to make those connections. Make sure that you make them properly. Why? Because it ensures that people don't get shocked or electrocuted and buildings don't burn down. All good reasons to make up proper connections. Until the next time, work safe.